Hi everybody, I want to tell you how to do the online lab you're going to do for waves. You're going to go to your D2L page, look under assignments. After you click that, one of the things that you will see will be waves lab. So you're going to click on that and hopefully you will see this, and hopefully we're looking at the same thing here. I see this worksheet. This is what you're going to be writing. You can see it has questions, and you're going to answer these questions. It's going to be your lab. So to do that, to get your data, you're going to click on this website. So click right on that. It'll open in just a second. And we will see this. You can skip all this, just come up here, click on the arrow for play. This will be up for a second. And then you don't want to pick sound or light, pick water. So click on that. And here we have this thing that can make waves. So now that you have the website up, you're just going to follow the directions on the lab write-up. So it says click on the green button, turn the liquid water dropping into a container filled with liquid water. It's the top view. Let about 10 drops of water hit the tank. All right, so I'm back on the website right here. So it says to click on the green button. So do that, just click on the green button. See that? So this is like if you were standing over like the basin of a sink or a tub, something like that, looking into it. So I've let about 10 drops hit. Then I can stop it. Right? If you're just playing with this, you just want to look at it. Here's the side view. So this would be if like your tank or your, let's get the side view. Oh, that's over here, sorry. This is your side view. So this would be like if the bathtub, if you could see through it, if it were clear and you're looking at this side. But you want to do this lab with top view. Okay, so let me move this guy so I can tell you about these things. Well, if I can. There we go. So this is the ruler tool, and you're going to use it right on here. And this is the stopwatch tool. So you can't use it up there. You have to bring it out here toward the waves. Okay. So at first, you're just going to let some drops go in, and you're going to answer these two questions. What does the dropping water create in the tank? Well, what are we talking about? What do you see as the liquid continues to drop? Just talk about what you see in terms of all the things we've been talking about. Then you're going to increase and decrease the amplitude setting by moving the amplitude slider. So let's go back to the web page for a second, and I'll show you what that looks like. So here we are on the web page. I paused this for a second. Let's play it again. And I moved my ruler onto there. So this is the amplitude slider. So here it is right in the middle. I can make the amplitude smaller. And I can make the amplitude larger. So play around with that, and then you're going to answer this question. Increase and decrease the amplitude setting by slowly moving the amplitude slider, and you are going to answer what happens to the actual drops of liquid, what's happening to them, and the waves created as you do that, as you increase and decrease the amplitude. So please note that there are two questions there that you're going to be answering. And then you're going to tell me what is amplitude according to your Hewitt textbook. If you don't have a physical copy of the book, that's fine. You have access to that text, as you know, hopefully, through Mastering Physics. So find the definition of the amplitude, read it, think about that, and answer that question. The next thing you're going to do is increase and decrease the frequency by using the frequency slider. Then you're going to talk about what happens to the drops of liquid and the waves as you increase and decrease the frequency. So let's see if we can get our waves back. And I'll show you that's this other control right here. So you can move it down and you can move it up. Okay. And when we get down here, you're going to have to actually collect some data. So what is frequency according to Hewitt? So again, you're going to go into that textbook, you're going to read the definition for frequency, and you're going to talk about that here for question number 6. So this is the wave speed equation that we have been over a couple times. Velocity is equal to lambda times frequency, and you know that lambda means the wavelength. And then f is the frequency of the wave. To measure the wavelength, you're going to use that ruler thing that I showed you. And to measure the frequency, you can measure the period with the stopwatch. So remember I showed you the stopwatch and I showed you the ruler. So let's look at those for just a second. So when I come here, to measure the wavelength is going to be really helpful to use this as the pause button. For now, let's measure the frequency. If I want to know how many times one whole cycle or how long it takes to complete a cycle, you know that when we talk about period, we talk about it in seconds. I'm going to hit start on my stopwatch that I've already brought down here. As soon as one of those drops hits the top of the virtual water, and then I'm going to hit stop as soon as the next drop hits. That's going to be one whole cycle, and that'll tell me the period. So here we go to the next one. Start, stop. So I have a period of 2.39 seconds. So I can't directly measure the frequency, but if I know the period is 2.4 seconds or 2.39 seconds or whatever you get, you can then figure out the frequency. Remember that that relationship we had where we had frequency is equal to, let's write it down here, 1 over the period. So we need a mouse here. 1, and then at the bottom, 1 over the period. So if my period is, for example, 4 seconds, that means my frequency is 1/4 of a hertz. Remember, our unit for frequency is hertz, and that really should be a capital H. So let's fix that. Maybe. There we go. So hertz is the inverse second or cycles per second. So if it takes me 2 seconds to complete a cycle, that means I'm completing 1/2 cycle every second. We talked about that a lot. So let's go back to the worksheet for a moment. Here's the worksheet. And that relationship, you're reminded of that right here on this lab write-up that you're doing. So since there can be many different waves in a given medium, you might be tempted to think that they can travel at different speeds. However, for linear waves, the wave speed is set by the properties of the medium, so that for a given experiment, the wave speed of all waves in that medium will be the same. So that's what you're going to test here, and that's what you're going to gather this data to show us. So what you want to do is you're going to use that ruler that I showed you. You're going to use the stopwatch that I just showed you how to use. And you're going to take and move the frequency slider, and on ours that's running, I already moved it there. So let's look at this. You're going to take and move the frequency slider over to the left so that it is 2 places to the right of the minimum position. What does that mean? So 1 place to the right, 2 places to the right. So your frequency slider should be, see how it's right on that line there. So that's where you're going to put your frequency slider. And then you're going to measure the period, okay? And then you're going to compute the frequency in hertz. The other thing you're going to do is you're going to measure the wavelength. So to do that, like I told you before, you're going to have to pause this. So pause. Remember, wavelength is crest to crest. So I'm going to take my measurer. I'm putting the start like right there. See, this is the start right here, not the middle of your tape measure looking thing. It's this thing here. So you want to make sure that that is right where you want it to be, the start of this ruler tape measure. And then you can extend it to wherever you want to measure to. So if I'm telling you from here to here, that looks a little long to me actually. I think probably to there. So it looks like my wavelength for this particular wave here is from here to here. That would be like 4.3 centimeters. Okay. So back to your write-up. Change the simulation to slow when you do this. So that will look like this. Right now it's on normal. We're not doing it. There we go. Change it to slow. But to go ahead and measure that wavelength, you're going to have to hit pause. So if I want to go right from the crest to the crest, right? So I'm in the like the brightest part here to there, the middle of this crest to the middle of this crest. So that's how to do all that. You're going to pause it, just like we said. You're going to measure the wavelength. You're going to start to fill out this table. So slide the frequency slider to one position to the right of the original setting. So if you're here to the right, you're going to go over here. So you're going to move your frequency and then set the thing running again, and then you're going to get a new period. From a new period, you'll be able to compute a new frequency in hertz, and you're going to pause that at some point and measure a new wavelength. Okay? You'll write the wavelength here, the period for that particular wave. You'll figure out the frequency, and then you'll compute the wave speed. You'll take that frequency, you'll multiply it times the wavelength you measured, and that will be your velocity in centimeters per second. You're measuring your wavelength in centimeters. And then you'll do it again with the other frequency. So you'll compute, you'll measure the period. From that measured period, you will compute the frequency, because remember the frequency is 1 over the period. You'll measure the wavelength, pause it, measure the wavelength, and then you will calculate this. You will do wavelength times frequency, and that will give you wave speed. So right now, I think it's clear with everything that I've talked about how to fill this table out. And you're just going to answer all the questions in this write-up. And then you need to submit this lab through D2L. So you're going to use equations 1 and 2 to calculate the frequency. So that just tells you that the frequency is 1 over the period. You'll calculate the wave speed with the wave speed is equal to the frequency times the wavelength. And then when you have that all filled out, you will answer these 2 questions. So please keep your work as neat as you can. And I have a due date set in there for you. If you have any questions at all about how to do this lab, just shoot me an email, or you know, you can use that phone number that's under my instructor information to call or text. So happy data gathering in your lab.